We're very excited by the findings that we're going to be reporting in this paper to Science at the end of this week. What we're going to report on is the discovery that bumblebee species across Europe and North America are declining at continental scales as a function of rapidly changing climatic conditions, and that is changing climatic conditions that reflect human activity. The rates of loss are unprecedented in terms of their geographical extent and the magnitude of those losses. We have seen declines of bumblebee species as their geographical ranges collapse inward because of rapid warming on the scale of hundreds of kilometers. To do this work, we looked at more than a century of observations for 68 species on both continents. These observations give us a pretty comprehensive look at the precise distributions for each one of those species through time and across continents. We have also been able to measure how environmental conditions change in both Europe and in North America with respect to a few different factors that are potentially very important for causing bumblebee ranges to shift around. Among these factors, of course, there's climate change, which we knew could be significant, but which we didn't think was going to be as significant as it has been. But also how habitats have changed across continents, and how, in some areas, rapid increases in pesticide and neonicotinoid insecticide use has changed. And what we're seeing is that neither habitat loss nor pesticide use is able to explain how the geographical ranges of these species are collapsing inward. Instead, the only factor that appears to be able to explain this trend is rapid warming along the boundaries of species' geographical ranges. The consequence here is that we are seeing wholesale losses of bumblebee species from places that used to be common, but that have become too hot for them to maintain populations. We have also observed, and again this is a first, that these species have been unable, in general, to expand their ranges into northern areas that used to be too cold for them. Other groups, like butterflies, have proven to be pretty good at expanding towards the poles in terms of their geographical distributions. The net effect being that as climate changes, the geographical ranges for many butterfly species actually gets bigger. For bumblebee species, the exact opposite trend is underway. As rapid warming proceeds, the ranges collapse inward. The consequence is that pollinators are declining over huge areas, and in the particular way that we've measured it here, those effects reflect climate change, but they do not reflect habitat losses or pesticide use, although those factors can certainly be important in some areas and for some species. We've also been able to track how the geographical ranges of these species have shifted along elevation gradients, and those results mirror the results that we've observed across continents quite well, giving us additional confidence that our results probably are sound. We have done one more thing here that is very unusual in terms of research at this kind of level, and that is we have made all of our data and analytical techniques publicly available, so that as the paper is published, anyone in the world will also be able to download all of our data and reproduce and evaluate all of the results that we have reported on in this paper to Science. So we're very excited by these findings. We think that we are in a position now to make specific management recommendations that we hope will enable us to mitigate some of the worst effects of climate change on these bumblebee species. One of the things that we're going to need to contemplate is what is known as assisted migration, where we transplant populations of bumblebee species a little further north and to places they are historically not present in, but where we think they need to go in order to maintain themselves. Our results suggest this may be necessary for large groups of species across continents. Moreover, the critical message here is that we need to get a handle on climate change. The effects are rapid and they are well underway, and they began at least 20 or 30 years ago. And it's only now that we're beginning to assemble enough data to detect some of those impacts. It would be impossible to expect anything else at this stage than that these effects will continue and probably become more and more extreme with time. So the consequences of losses of pollinators over large areas is both economic but also practical in terms of diminished food security and in terms of rising food prices. We need to get a handle on climate change once and for all.